Okay, so in your Canvas, I've put two PDFs, and they're CUDA worksheets. And one is called Factoring Trinomials, and the other one is called Factoring by Grouping. So both of these together make up your lab. And the nice thing about these is they give the answers. Now the answers are in red. The printers here at the university only print in one color. So, but you can check these. And if you look at them in your computer on your laptop, you'll see that the answers are in red. Okay. All right, so when you're factoring a trinomial, there's a trick you can use. If the leading coefficient here is just 1, and so the variable here is b, and you can see there's no number out the front, so it's understood the leading coefficient is 1. There's a trick you can use, and are there two numbers whose product is equal to this number, but at the same time whose sum is equal to that number? And if you can find two integers that do that, then you can factor it. So when this says that a is equal to 1, a trinomial is something in this form. And if our variable's x, so if a is equal to 1, then it just appears like that. So all of these are trinomials with a equals to 1. The variables are different letters than x, but that's okay. So we can find two numbers that multiply together to give us 7, but at the same time they add up together to give us 8 and 1. So the two numbers that do that are 7 and 1. Now, when you find those two numbers, you can factor it. And this is written with respect to b. And then the order doesn't matter, so I'll put 7 and 1. And that's it in factored form. And you can always check it. You can go back and FOIL it and expand it, and you'll get what you started with. Okay. So let's look at something like this one. We need two numbers whose product is negative 90. But at the same time, their sum has to be the coefficient there, which is understood to be 1. Now, negative 90, we could have negative 10 and 9. That would give us negative 90. But what happens when you add those two numbers together? You get negative 1. And that's not going to work. It has to work both times. So there's also positive 10 and negative 9. Will that work? 10 times negative 9 is negative 90, and 10 plus negative 9 is positive 1. Those are the numbers that work. So I can factor this now. My variable is m. And again, the order doesn't matter. I'm going to have positive 10 here, and I'm going to have minus 9 there. And if I multiply that through and expand that out, I will get back to my original. Okay, what about this one? Two numbers that whose product is negative 12, but at the same time their sum is positive 4. How about positive 6 and negative 2? So 6 times negative 2 is negative 12, and 6 plus negative 2 is positive 4. And our variable here is n. And so plus 6 and minus 12 should work. Okay, now what do we have here? The product has to be positive 24, but the sum has to be negative 4. So if I only have positive numbers for my product, then when I add them up, I'm not going to get a negative number. So how could we get positive 24? Well, we could have negative 24 and negative 1, but when I add those together, I get negative 25. That won't work. I could have negative 6 and negative 4. That will work on the product because when I multiply those together, I got positive 24. But when I add them up, I get negative 10. So that's not going to work. I could have negative 8 and negative 3, but that won't work on the sum. I could have negative 12 and negative 2, but that won't work on the sum. So the trick doesn't always work. And I've exhausted all of my possibilities there, and we can see that it's not factorable. Now, another term for this, instead of not factorable, is to use the word prime. And in WebWorks, they'll tell you to use the word prime if you cannot factor it. Okay, what about this? Are there two numbers whose product is 40, but whose sum is negative 13? Well, again, my two numbers are going to have to be negative numbers. 4 and 10, negative 4 and negative 10. If I multiply those together, I get positive 40. If I add them together, I get negative 14. That's not going to work. Well, what about 8 and 5? So for this to work, negative 8 and negative 5. If I multiply those together, I get positive 40. If I add negative 8 and negative 5, I get negative 13. I've found the two numbers that work. My variable is k here. And so that is how I will factor that one. Okay, so I'll leave those. No, I might have one more. Okay, negative 56 is what the product has to be, and the sum has to be negative 1. Okay, well, we know that 8 times 7 is, or 7 times 8 is 56. Now I need the product to be negative and the sum to be negative 1. So I think negative 8 and positive 7 is the combination I'm going to be there. When I multiply those together, I get negative 56. When I add those together, I get negative 1. Okay. So there is a CUDA worksheet, and it has the answers in the back of them. And in the second part of the lab, they want you to do something called factoring by grouping. When you factor by grouping, you have 4 terms. And so you consider the first 2 and the second 2 and see what you can factor out of that. Let me try one that actually has something nice in there. Okay, so for this I can factor out an 8, and I can also factor out an r squared. So for that first term there, I'm going to be left with r minus, and 64 divided by 8 is 8, and the r squares cancel out. And these have nothing in common, so I'm just going to put a 1 out the front. Now, what do these have in common? They have an r minus 8 in common, so I can factor it out. And what am I going to be left with here? Well, I'm going to have 8r squared plus 1. And that's how factoring by grouping works. Let's looking what we have there. Okay. So let's see what else we can do. Let's try and do that one. Okay. Well, they have a 5 in common and a v squared in common. So I'm left with that. These have a 6 in common, these two terms. So we can see here now that I'm going to factor this out, and what's going to be left in here is going to be 5v squared plus 6. Okay. All right. When I look at these, 16 is 8 times 2, but it's also 4 times 4. 28 is 4 times 7, so I'm going to factor out a 4 and a v squared. Now, since the leading term is a negative here, I'm going to factor out the negative. 21 is 7 times 3. 12 is 4 times 3. I'm going to factor out a negative 7. Now, when I divide each of these by negative 7, I'm going to have left a, I'm going to factor out a negative 3. Because that's common to both of them. When I factor out a negative 3 from this, divide negative 3 by that, the negative signs cancel and I have 7b left. And negative 12 divided by negative 3 will be positive 4. And then I have my common factor. And what goes in here is going to be 4b squared minus 3. Okay, so that's the kind of thing they want you to do for this lab.